Hello all, welcome back to Sri Sai Tech Edu YouTube channel Read Lead Success. I am dealing with the subject Network Analysis and Control Systems. Module 1 and Module 2 consists of Network Analysis, where I have already uploaded in my channel Module 1 and Module 2 complete. And now I am dealing with the Control System part, that is Module 3, from Module 3 to Module 5. In Module 3, some of the topics I have already uploaded in the channel. Now I am going to deal with the one of the topic in this video. I've already uploaded the videos on the introduction and types of control systems and effects of feedback systems, modeling of mechanical system elements and electrical systems. In this video, I'm going to deal with analogous systems. Analogous systems. Comparing equations for mechanical translational system or for the mechanical rotational system and for the series electrical system, it is seen that they are identical form. As I discussed in the previous two videos also, that what I told, mechanical translational system and mechanical rotational system need to be converted to electrical system so that they are identical form, they are analogous. So it can be converted from mechanical to electrical and electrical to mechanical, like mechanical translation system to electrical, electrical to mechanical translational, mechanical rotational to electrical and electrical to mechanical rotational system. So they are analogous system, they are of identical form. Such systems whose differential equations are identical form are called as analogous system. They are identical form. Only the notation will be changed, but they are identical form, right? So the force, torque and voltage, force, torque and force voltage are the analogous variables here. So this is called force, torque, voltage analogy. Now we will see first force or torque voltage analogy. Force voltage analogy or torque voltage analogy. Force voltage analogy is for mechanical translational system and torque voltage analogy is said for rotational system. For this rotational system it is torque voltage analogy. For mechanical translational system it is force voltage analogy. So we will compare how force in translational system is force and in rotational system is torque, and electrical system is we are going to represent in form of voltage, that is E, and mass is m in moment of inertia J in mechanical rotational, we represent as inductance in electrical system. In translational system, viscous friction coefficient, that is nothing but it is F, that is damp circuit or viscous friction coefficient, that is F. It is either F or B. Here also it is either F or B can be represented. In questions, in question paper sometimes they give B, and resistance R. In terms of electrical system it is R, and spring stiffness K, and torsional spring stiffness also K, and reciprocal of capacitance is in electrical system. So if you want to convert the spring stiffness or the rotational torsional spring stiffness, we need to convert into 1 by C. So we need to write 1 by C in the equation. Whereas here displacement and velocity, we represent any equation in terms of displacement and velocity also. In mechanical rotational it is theta, that is angular displacement and angular velocity, whereas in electrical system we represent in terms of theta in terms of Q and omega in terms of I, that is nothing but Q and I. Okay, in the same way we have force current analogy. We'll see in the next slide. Similarly, comparing equations of mechanical translational system or the mechanical rotational system for parallel electrical circuit system. In previously they are series electrical circuit, whereas parallel is nothing but force current analogy or torque current analogy. As you can see, force current analogy, torque current analogy, and they are also of identical form. So analog quantities in force current analogy or torque current analogy, we will see force F is same, torque, and here we write in terms of current I for electrical system, and in mass M, here moment of inertia J, and in electrical system we represented by capacitance C, and viscous friction F or B. Here in reciprocal of resistance is represented in electrical system. Spring stiffness is same in both sides, but for electrical system we represent it in terms of 1 by L. Displacement and velocity, here angular displacement, angular velocity, here we represent in terms of magnetic flux linkage and voltage E. So this table and previous table you should know. Why? Because in questions they are going to ask, they give the mechanical translational or rotational system, and they'll ask us to write the differential equations and write the analogous electrical system for force voltage, force current analogy, or torque voltage, torque current analogy. If it is rotational system, they'll ask for torque current and torque voltage analogy. If it is translational system, they're going to ask for force voltage and force current analogy. So we need to know the representations to convert from translational to electrical or rotational to electrical system in terms of torque current or force current. In the same way, for force current or force voltage or torque voltage analogy, we need to know the things how to represent in respective systems. Either from mechanical to electrical system, we need to know these tables. These two tables are very important. So using these tables, those differential equations, we are going to solve some problems that I am going to do separate video. All the problems related to mechanical rotational system separate and mechanical translational system separate video. Translational systems I'll do separate video and rotational systems I'll do separate video, so that it will be easy for you also. By this we completed analogous systems. Now, as I said in the previous two videos, based on these 4, 5, 6 topics, I am going to do the videos for the further videos. I am going to do separate videos on the rotational and translational systems after this from the next video. Then after the problems, I'll do the block diagrams and signal flow graphs. I hope you are understanding. So I'm doing after this 6 topic, I'm going to do the problems based on these 4, 5, 6 because it will be easy, so that you should know the topics first 4, 5, 6. Based on that only the problems are based. So now I'm going to stop this video here. Thank you from Sri Sai Tech Edu YouTube channel. Read, Lead, Success. Keep reading.